Welcome to a lesson with Dr. Powell. Let's talk about polar coordinates and what they are a little bit. So we have something called Cartesian coordinates, X and Y coordinates. We have an X-axis and a Y-axis, and we can represent positions on the plane via coordinates in Cartesian coordinates. So we could have something like 3, 1. Well, likewise, we have something called, so this is Cartesian coordinates, something called polar coordinates. We can represent the points in the plane or where we are in another way. Namely, we could say how far we are away from the center, the origin, and we could also say what the angle is made with the positive x-axis in a counterclockwise manner. So in this particular case, 3, 1, we could actually write this coordinate down in polar form, where we have r, theta, where we need this distance from here to here, which we can by thinking of a right triangle, 3 and 1, using the Pythagorean theorem. So the square root of 3 squared plus 1 squared, which would be square root of 10. So r is square root of 10. Now, what would theta be? Well, in this triangle, we could simply say it's the arc tangent of 1 over 3, perhaps. That's one way of doing it, but nonetheless, we get it, or we could have used an arc cosine or sine using something like 3 over square root of 10 or 1 over square root of 10 as well. But nonetheless, we get the angle and we have how far away we are. Now, one thing about polar coordinates is that there are many representations of a single point in polar coordinates. Here's some examples. For instance, let's suppose that we we have this point right. This point right here, and let's suppose that it's 2 away, and we have an angle of pi force. So we have 2 pi force is one representation. Well, we could also use this angle and we'd get to the same point if we, from the positive x-axis going this way, for a negative, and that would be negative 7 pi force. This also works. And likewise, we could add 2 pi to either of these. So even 2, 9 pi force would also be a point that we could get to this if we went around to there. So there's multiple ways of representing this point, but that's not all of them. Of course, there's infinitely many, but there's other ways of thinking about this. For instance, what if we put down a negative 2 here, meaning we're going, meaning we can be like on the opposite side, going the opposite direction. So even if we did something bizarre, this is 5 pi force, like saying 5 pi force negative 2, that would actually land us at the same point, because we go to the ray at 5 pi force, which is in this direction. Then we, instead of going 2 along it, we go negative 2 along it backwards to get here. So this is yet another representation of the exact same point. So in polar coordinates, we have many different ways of representing single points, either by changing the angle or changing the angle to the opposite position and making the r value negative to go back. Thanks for watching.